Hi. So I thought I'd make a YouTube video. So today I guess I'm gonna be working on my calculus homework while I talk about some things. Um, so I'm working on exam number 3. We have a test on Monday. Today's Saturday. Or sorry, test on Tuesday. Today's Saturday. So gonna I've already done the review, already done it, but I think I'm just gonna do it again because I'm a little shaky on it. So what I'll do is I'll open up a new PDF. I like to use Cammy. I know there's other ways to edit it, but it's just what I've always used. Empty 3-page document. And we'll call this delete later. Because I really don't want to save this. Um, it's really just for practice since I already have all the work done. So now I'm going to pull up well, I'll start from the bottom. Because I started from the top earlier. So I guess the instruction is to use a power series to approximate the value of the definite integral with an error of less than 0.0001. Okay. So, first of all, we need to find the power series for ln x. And I don't know if we're supposed to have this memorized or not, but I don't. So I'll just pull it up. So this is the power series for ln x. I'm just going to write this part down. I guess it should be a series. Times x to the n, x minus 1 to the n. Yeah. And it's n equals 1 because of this denominator. It can't be n equals 0 because then it would be dividing by 0, and you can't do that. So here we have the power series for the natural log of x, and in our equation it's being multiplied by x, and you can just add that in. Or hold on. First of all, let me write this series as, you know, a bunch of polynomials. So we'll start at 1, -1 to the 1 minus 1 times x minus 1 to the 1 over 1. And I'll simplify this later. Plus -1 to the 2 minus 1 times x minus 1 squared over 2. I guess I'll go to 4, I think. -1 to the 3 minus 1 times x minus 1 to the third. The reason I'm doing this YouTube channel is I felt like I was kind of meandering around, wasting my time, not providing much to the world. I thought it'd be neat to give it a shot. You never know unless you try it. So let's simplify this a little bit. Or do I want to? No, I don't want to simplify this yet. So then we have x times the ln of x. And I'm not going to write this series again. I'll just write this series. I'll just write the... There should be... I don't know if there's a word for the... This is a series, but I don't know what this... This is also a series, but there's clearly a difference. I don't know what the word for that is. Edit. To show that it continues. Okay. So we can just multiply by x. So we got -1. I guess I can go ahead and simplify this as I'm writing it. So -1 to the... Or no. I'm going to simplify the regular natural log. This becomes a 0, anything to the 0 power, so we don't need to write that, times x minus 1 to the first power over 1, plus -1 to the first power is -1, so let's just make that a minus x minus 1 squared over 2, plus minus 1 is 2, -1 squared is positive 1, plus x minus 1 cubed over 3. 4 minus 1 is 3. -1 cubed is -1. Put a negative. And just write that down. X minus 1 to the 4th, or 4. Plus dot dot dot. Then we multiply by x. And when we do that, we can just, pretty simple, you just multiply by x. Oh. I guess we also need to have x plus 1. So this is what I have right now. And I don't know if I need it to be like that, or if I need it to be like that. Where, does this need to have the x plus 1 in it as well? I don't think so, but maybe. I'll check, see what I got when I did this earlier. So let's have x, let me write this in a way that's clear. X plus 1 minus 1. So these parentheses, these two cancel out. Left with x times x, which gives me x squared minus, let's get that 1/2 out of here. This x minus 1 is going to be the same thing, it's going to be x. So we're going to have x times x squared, going to be x cubed over 2. And I guess it's going to be the same thing here, where we have x times x to the first times x to the whatever this is. It's going to be x to the 4th over 3 minus x to the 5th over 4 plus dot, dot, dot. And hold on, let me write this a bit nicer. Yeah, so that's what the series this is equal to. And I guess I have to integrate that. From 0 to 0.25. Let's go x squared minus x cubed over 2 plus x to the 4th over 3 minus x to the 5th over 4 dx. Is that right? That looks good. Well, no, hold up. Dot 3x. So let's just integrate this. Equals, use the power rule. We got x cubed over 3 minus, pop that fraction, 1/2 of x to the 4th over 4, and then combine that back together to be x to the 4th over 8 plus, pop the fraction out again, x to the 5th over 5, put them back together, x to the 5th over 15 minus, do the same thing, x to the 6th over 6th, yeah, x to the 6th over 24, evaluated from 0 to 0, 1, 2, 5. Okay. And so, usually you'd want to evaluate this and find out whichever, what this is called, whichever piece of the polynomial is, less than 0.0001, because if you remember, that's up here. So whichever number is less than that, you can, from that point on, that way, you can ignore all these numbers. All right. So I guess we'll start with the 6th. So we have 0.25 to the 6th, that's not 6, over 24. And I'm not going to do any crazy arithmetic. Oh my god. Let's just make this easy on ourselves. Well, you can't see this other tab, so I'll close that. $0.25 to the 6, oops, divided by 24. There we go. We got 1, 2, 3. It's definitely less than 0.0. So we don't need that. Let's test this one. 5th over 15. Let's try that out. 0, 1, 2, 3. Boom. You don't need that one. New numbers. All right. Let's try this out. 0.25 to the 4th over 8. 2, 3, 4. Okay. So this one, we need this one. Okay. So let's put a little kind of equal to, approximately equal to x cubed over 3 minus x to the 4th over 8, evaluated from 0 to 0.25. Which is gonna be, you know what? Just make this easy on ourselves. 3. What is it? 3. Is that correct? Did I integrate that correctly? I did. Minus 0.25 to the 4 over 5. Alright, 0.0047. Let's see if that holds up. I'm a little bit suspicious because it's so small. Yeah, it looks about right. Graph it. This one, what's it? So 0, x equals 0.25. If you zoom in, yeah, that looks about right. Okay. So that's how you integrate something that you can't integrate using Taylor? Yeah, no, Maclaurin polynomials. Same thing. Alright, let's get this one. We're just doing the same thing. I'm thinking moving, because I've only talked about doing math, and I haven't explained myself too much. It's not like I'm telling you how to do this, you know? So I'm not giving you any important information. So I think moving forward, I might just record myself doing some homework or playing a video game or something, and then separately record audio of myself saying something more clear, more articulate. But for now, this is what we got. See how long I've been going for. 18 minutes. 18 minutes for one problem? Well, I wasn't trying to make it fast, so that's alright. Okay, so let's do this. First of all, let's get that e to the x. Let's see, I'm pretty sure I can remember this one. This is an easy one. What series is e to the x? That's over n factorial. And n squared, no, that's not right. Ooh, I can't remember. Ooh, it's the definition of e. It shouldn't be hard. But x to the n, I forgot the letter x. If I remember there was an x in there, I bet I would have gotten it. So let's do that. What are we changing? We're changing, there's a negative x squared. So, you know what? Last time I wrote out the series, this time I'm just going to write the series. 0 to infinity of negative x squared to the n over n factorial. You can break that down a little. That's going to be negative x to the 2n. I don't know why it took me so long. But alright. Now let's write this out for real as a polynomial. We got, starting from 0, we'll write this non-simplified. Negative x to the 2 0 plus I feel like there's a better way of writing this. Because I don't know if it's like that or if it's like that. Oops. You know, pretty sure it's the former. Yeah, let me clarify. So this is always going to be positive. So I'll just get rid of this negative sign. Alright. That doesn't need to be an n. Okay. Let's get this rocking. 1 factorial x to the 2 times 1 plus x to the 2 times 2 over 2 factorial plus x to the 2 times 3 over 3 factorial plus x to the 2 times 4 over 4 factorial. That's pretty good. I think I'm going to go to 4 every time. Simplify this down. We got x squared plus x to the 4th over 2 plus x to the 6th over 6 plus x to the 8th over 24. The way I do factorials is, or especially in this type of situation where I'm doing every repeated factorial, I just take this, I know that 3 factorial is equal to 6, so I know 4 factorial is equal to 6 times 4. The reason for that is because the definition of factorial. As you can see, you just multiply it by the next one. So 4 factorial equals 4 times 3 times 2 times 1. And 3 factorial equals, let me try and line this up, 3 times 2 times 1. So if we have this group, and we just multiply it by 4, we get 1 factorial. That's what I do anyway. Makes it a lot easier. You don't have to keep multiplying the same numbers over and over again. It's easy to remember too. Hold on. Let's add this. Dot, 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 dot. I always forget that. So let's integrate that from 0 to 0 0.5, 1 plus x squared plus x to the 4th over 2 plus x to the 6th over 6 plus x to the 8th over 24 plus dot 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 dx. For this test, I'm not too worried about it. I feel like I'm pretty good at these, so I'll be alright. What do we got? Yeah, but yeah, for sure, for upcoming videos, if I make any, I don't know if I'm even gonna upload this, but if I make more videos, I'll for sure make a. I wouldn't make a script, but I'll make points that I want to talk about, and then like record myself doing something. You know, to make it actually entertaining. What is that? 8, 4. Until now, got the best of me. 0 to 0 0.5. So we got to figure out which one is the correct one to start at. So we got 0 0.5 to the 8th over 192. Put that in. It's for sure less than what we're looking for. Yeah, 0, wrong color. 0 0.5 to the 8th over 42. It's not an 8 to the 7th. 0.0018. You remember what the rule is. The number has to be less than 0.001. This is slightly bigger. Get rid of that. I'm not even going to check the next one because it's definitely going to be less. Oh, wait. So this one is bigger. This one is less. So I don't do this one. I do this one. These. So, oops. I believe equals x plus x cubed over 3. Just copying it down. Plus x to the 5th over 10 plus x to the 7th over 42. Evaluate from 0 to 0 0.5. And that is 5 to to the 7th, about 42. 0.5449. Um, call it 7, oh, 8, because it rounds up. Alright. Let's see what I got before. 0.545, 54. Yeah, I want to make sure I'm rounding it correctly. Because I should just be doing what the calculator's doing. Oops. Come back. Squared. It's not good. 0.1 off. That's really bad. So I'm too worried about it. I've been at this for about 30 minutes. I only did 2 problems and one of them was wrong, but that's okay. I'm just gonna, I don't know, make a YouTube channel and upload it and see what happens. And I'll probably right after this record more math homework so I can have something to put in the background for the next video when I actually talk about something. And then I gotta figure out what I'm gonna talk about. But yeah, it's been a good one. I hope I make a couple of these videos at least. Yeah, have a good one.